That's right, kids. Time for another test. And the only promise I can make you when it comes to tests in my class is that I promise never to do like this guy. Classwork, 2 + 2 = 4. Test. John had 3 apples. He lost 1. Calculate the mass of the sun. Which rhymes in a cutesy kind of way, but I will never do that to you. Anything that's on the review is fair game on the test. Let's take a look at the review that you got in class. All right, for this test, you must know the coordinate plane, the vocabulary that goes with the coordinate plane, and graphing and finding ordered pairs on a graph. I'm not giving you a review for that. You should be pretty comfortable with that at this point. If you have a need to practice it, we can find you an IXL skill on the 6th, 7th, or 8th grade skills. Also, you need to be able to use graphs and relate to quantities. So all the way throughout this review, you'll have some problems, like this one, that require us to write out some work in the video, and then you have some that are indicated that just give you the IXL skill. So if you know you struggle between independent and dependent variable, there's your IXL skill. All of these skills are listed for the algebra section, not the grades 6, 7, or 8. So it doesn't matter what grade you're in, they're listed for the algebra 1 section, algebra 1. Which is with a Roman numeral most of the time when you see it. So anyway, let's do this one. You ride your bike to the park. Sit and read for a while, then ride back home. There is less traffic on the way home than on the way there. Sketch a graph to represent your distance from home over time. Okay? Distance from home over time. So this is distance from home. And this is the time that elapsed. Well, shoot, I'm not a grammar teacher. That's a good thing. All right, so as you go up, distance from home increases, and as you go from left to right, the distance from the time increases. So you're starting at home, and you ride to the park. You hang out at the park for a while, and then you go home. But look, here's this last part here that makes this a little bit different, that changes what we have to draw a little bit. There's less traffic on the way home than on the way there. That means that you were able to cover the same distance in less time. So that's how that would affect that. So hopefully you got generally the same thing. All right, moving on. All right, for relations and functions, I need you to be able to determine if a relation is a function. Excellent IXL skills for that. This one's from a table, Q4. Q5 is from a graph. They are on the challenging side, but they are excellently explained if you need help. Take a screenshot and send it to Miss LeCompte. Might as well take advantage of iMessenger before we might possibly lose it. If I haven't talked about that in class, it's a possibility they may be taking it away from everybody. So always send me a screenshot if you need help with something while you're studying. The next thing you have to be able to do is find the domain and range of a function. When it's a discrete function, there's an IXL skill for that. So we talked about this in class. Discrete is individual points. So that would just be a graph with dots, and you're telling me the domain by telling me the x values, the range by telling me the y values. And then find the domain and range of a function when it's continuous. So when it's continuous, you have a different circumstance altogether. You have a graph, and I have 3 here that we will practice with. So for the first one, you have a V-shaped graph. That's an absolute value function for those of you who didn't hear that when we talked about it in class. That's an absolute value function for those who didn't hear it when we talked about it in class. So what's the domain and the range here? Well, the domain has to do with moving to the left and the right. Well, this graph will go forever to the left, forever to the right, forever to the left without stopping, and it doesn't have any breaks in between. So the domain for this one is all the real numbers. The range, however, is going to be different. The range is anything from -1 up. Anything from -1 up. Notice there's no y values on that red graph below that. So the range is anything from -1 up. That's y is -1 or greater. Domain and range. A linear function for the next one. Our linear function has a line. It's going to keep on going forever to the right, forever to the left with no breaks. Forever up, forever down with no breaks. Both your domain and your range, all real numbers. All real numbers. And the last one we have here is a parabola. Parabola, not parabola. And on this parabola, again, x forever to the left and forever to the right, so our domain is all real numbers. Now, it makes sense for all of these to have a domain of all real numbers, because when you have a continuous function, most of the time, its domain is going to be all real numbers. Most of the time, its domain is going to be all real numbers. All right. What about the range? What about the range? Well, in this case, the range is anything from 3 and down. Anything from 3 and down. So that means y can be 3, but it's also smaller than 3. So 3 and down. Okay? Moving on. Set of skills, you have to be able to display a relation in each of 3 other ways. I gave you the list. So this right here is a list. You need to be able to also do a table, a mapping, and a graph. Okay, the mapping is the only one that you're going to have to go back and go, what's a mapping? Because that is something we did need to know how to do. Okay, we do need to know how to find a mapping. So let's start with the table. The table is easy. X, Y. Put your X's. Let's not do that one next. Let's do it in numerical order. So X could be -2. There's another -2, a -1, and a 3, and a 6. Those are all my X's. And -2 and 5, -2 and 9, -1 and 9, 3 and 2, 6 and -1. So I just took the ordered pairs, and instead of being a list of ordered pairs, I turned it into a table. All right, how about a mapping? A mapping is where you take and you make 2 ovals. You put your X's, -2, -1, 3, and 6 with no duplicates on the mapping. Okay, this is a mapping again. This one over here, this one was the table. Anyway, no duplicates. Now look at my Y's. I have 5, 2, 9, and -1. So -1, 2, 5, and 9. 9 is used twice. All right, -2 goes to 5, so I draw an arrow to 5. 3 goes to 2, so I draw an arrow to 2. -2 also goes to 9. That's going to be significant in a moment when we take this question a step further. 6 goes to -1, and -1 also goes to 9. Now, here's a quick question. Is this a function? Because I have a really quick and easy way to tell. And you have a mapping. If you look at the arrows coming off of the individual numbers in the domain, if any of those have 2 arrows coming off, then it is indeed not a function. Not a function. All right. Last question or last part of this particular one is making a graph. You know what? I'm not going to make the graph. You guys know how to graph. We already covered that on a previous thing here. But do be able to take a relation and put it in the format of a graph. Function notation. Evaluate a function rule for a given value or a set of values. There's IXL skills Q.7, Q.8 for this, again, in the algebra section. If you're given a domain, find the range. So I gave you 2 functions, gave you a domain, we're going to find the range. So let's do I first. So f of x equals -2x minus 3. And we're going to plug each of these values in the domain in and get a range. So that means we find f of -4, f of -2, f of 0, f of 1/2, and f of 4. Pause it, go through and do that. I'm going to go ahead and actually pause mine and write it out to make the video go a bit faster. And again, you should be pausing it. You actually should have done this whole thing before you watch the video, you know, just to be clear here about the rules. But if you didn't, pause it now and do it now, please. All right, I'm going to get ready to pause my video. I'm going to write it out, and then you can take a look at the answers. And there you have it. So we plug each of the numbers from the domain in, and we find the range. Now notice when I stated the range at the end, I still stated it in numerical order from least to greatest with curly braces around it. It does not correspond to the order these were in up here, because when we talk about domain and range, the notation is to put it in numerical order with curly braces. Okay, this is one of those fun arbitrary things that we don't really like doing. But if I have a function rule and I need to plug in the domain, that's how you do it. All right, let's try the next one as well. All right, the function rule on this page is the second one, g of x equals 5x squared plus 3. Do the same thing. Pause it, set it up if you haven't already done it. If you already did it, then in a moment, you'll go ahead and you'll see the work all written out. I'm going to go ahead and pause it and write it out. All right, here it comes. And there you have it. This range only has 4 values in it because 2 of the values that we plugged in for x gave us the same value in the range. And that's actually quite common with a quadratic with an x squared in there, something we'll see more of in third quarter. So again, to find the range, you plug in the domain, find the range, make sure you try to express it correctly. To linear functions. Be able to determine if a function is linear or not. And we are, at this point, we have worked on that in class, so that should be something you know how to do. If you need extra practice, shoot me an email, and I'll find something for you to use. Write a function rule for a given situation. That's Q point 10 on IXL. That's the word problems. Graph the function rules, which we'll do in a moment. And then identify a function rule to match a table when you're given choices. I'm not going to make you find a function rule from scratch. We established in class that was actually pretty tough, and that in reality, it's best for us to have a method and not just to be trying to grasp at straws or do trial and error. And that's IX skill Q point 12. And again, it's multiple choice for those. Okay, let's do some graphing for function rules. Saw some great work on this in class. Folks definitely remembered how to do this. If you don't remember, well, then start off by making a table of values. So you're going to pick some values that work, and we're going to do h of x first. So we pick the x's, we plug it into h of x, and we're going to get ordered pairs to plot on our graph. I'm going to use -1, 0, 1, and 2, and we're going to multiply each one of those x's by -4. So that gives me +4, so the first ordered pair is -1, 4. Second ordered pair is 0, 0. The third ordered pair is 1, -4. And the fourth ordered pair is 2, -8. Now we plot them. 2 -8 is not going to fit on my graph. Bummer. That's okay. We'll graph what we can. -1, 4. Plot, 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 plot. 0, 0. Plot, plot, plot. 1, -4. Plot, plot, plot. And 2, -8. Well, this is 7, so it's darn close. We'll put it there. And it does indeed make a line. This one is linear, which we should recognize because what we talked about in class was x to the first power and no other weird operations. No absolute value, no x squareds, no variables in a denominator. That's another thing that will give you something nonlinear. All right, last problem on the test review. Is g of x here, 2/3 x plus 1. Well, first of all, let's think simpler here. We talked about this with a warm-up question. You don't want to pick numbers that make your life harder with these problems. You want to pick numbers that make your life easier. In this case, you want multiples of 3. So I'm going to do -3, 0, 3, and I guess 6. I think that should fit nicely. So 2/3 of -3 plus 1. 2/3 of -3 is -2 plus 1 is -1. So my first ordered pair is -3, -1. It is perfectly acceptable if you need to use a little bit more space to write it out. I did that a little fast. We're at the point where with fractions we should be pretty comfortable though. So if you need extra help with fractions, don't hesitate to come in. Plug in a 0, we get 1 out. So 0, 1. Plug in a 3. 2/3 times 3 would be 2, plus 1 would be 3. So 3, 3 is on this particular function. And 2/3 of 6. Plus 1, 2/3 of 6 is 4, plus 1 is 5. So 6, 5. And this one's much nicer. Everything fits happily on this one. -3, -1. 0, 1. 3, 3. We can see the pattern here, making a line. And 6, 5. So some of you may remember some things you learned last year. Try not to jump in and force the issue. If you don't remember how slope and y-intercept work, don't worry. We're coming up to that next week. Well, probably next week. Okay, guys. That's it for your test review. I'm confident you'll do quite well on this test. If you need help, send me an email. I'll be happy to help. See you in class.